Hi guys, so in this video I'm going to show you how to draw a Lewis structure of an ionic bond between atoms. So we're going to start with the first problem, which is sodium chloride. So I'm going to start with a sodium atom and I'm going to find it on my periodic table. And I find that sodium is in group 1, the alkali metals. So because it's in group 1, it's going to have one valence electron. So I'm going to draw my symbol with its one electron. Now, sodium is a metal. It has one electron. And when we're doing these ionic bonds, we have to remember that their goal is to transfer their electrons to look like a noble gas, to be stable. So while some of these atoms are going to get rid of the electrons, like sodium here, others are going to gain electrons. And that's the case with chlorine. Chlorine, if I look at the periodic table here, is in group 7A, the halogen family, which is a nonmetal. And nonmetals are going to gain their electrons. So I've got my symbol for chlorine, the 7 electrons. So what's going to happen is sodium is going to donate its electron to chlorine. When it gets up its electron, the atom becomes positive. Okay? You're giving up a negative electron. So that means there are more positive protons in the center of that atom than there are electrons. So since it's giving up an electron, it's a +1 charge. Chlorine is going to then receive that electron, so it is going to be a -1 charge. Now, just as a review, sodium being positive after losing that electron will form a what's known as a cation. Okay, so it'll be a positively charged ion. And chlorine, having gained that electron, is going to form an anion. Now, in terms of chemical formula, I'm going to look and see how many atoms I've drawn for my Lewis structure. So I've drawn one sodium and one metal, or one sodium and one chlorine, and the metals are going to come first. So my formula is going to be NaCl, sodium and chloride, and that's the name. Okay. I'm going to carry out the same process for number 2, potassium iodide. So I'm going to look for potassium on my periodic table. Potassium is in group 1 again. It is part of the alkali metals. So I'm going to draw my symbol for potassium with its 1 electron. I'm also going to look for iodine. All right, iodine is also in group 7A, the halogen family. So it will have 7 electrons. So I'll draw those 7 electrons. 1, 2, 3, 4, 5, 6, and 7. So again, these atoms, they want to be stable. They're going to try to look like a noble gas. So potassium, it's going to be easier for potassium to lose that electron, go back one space and look like argon. So it has, 19 electrons. If it loses one, it looks like argon here. Iodine, it's going to be easier to find an electron for iodine and move over to look like a xenon and be stable. So that's what happens. Potassium is going to give up its electron to iodine. When it gives up an electron, it becomes positive, in this case by 1 charge. Iodine has gained an electron, and it's going to be negative by 1 charge. All right, I've only drawn one metal, which is potassium, and I've drawn one non-metal, which is iodine. So metals go first. My formula is potassium iodine, which is also the name. And then we spell it iodide in a compound, so we just change this last three to an IDE ending. Okay. I don't know if I mentioned that before, so that's why it's chloride. All right, the next one, magnesium and oxygen combined together. So I'm going to look at my periodic table. Magnesium is in group 2A, the alkaline earth metals. Okay, so it's a metal again, and it has 2 valence electrons. I'm now going to find oxygen. Oxygen is in 6A. It is a nonmetal, and it has 6 valence electrons. So magnesium is going to give up its electrons to oxygen, and it's going to become a positively charged ion now, which we call a cation. Just to review, it becomes a cation. Oxygen is going to gain 2 electrons. So when it gains those electrons, you have to remember again, electrons are negative, so it's going to gain a -2 charge. And when it's gaining, it's known as an anion. So metals will always form a cation. Nonmetals will always form an anion. Now my ratio for my formula is still 1 to 1. I've drawn 1 magnesium atom and 1 oxygen atom. So it's still NGO. And my formula now is magnesium. Oh, almost misspelled it. Oxide. Okay. I'm actually going to skip down to question number 5, and then I'll let you do the rest on your own. We have a calcium and a chlorine. So again, I'm going to look at the periodic table. Periodic table is very important. I'm going to see that calcium is in group 2, the alkaline earth metals. So it's going to have 2 valence electrons. I'm going to get out that periodic table again. Look for chlorine. Chlorine here is in group 7, the halogen family. Okay, so it's going to have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. All right. So calcium, being a metal, is going to give its electron to chlorine. And this chlorine is now happy because it meets the octet rule. It has 8 valence electrons in its outer shell. Calcium, though, it's still not happy because although this atom is now filled, it's now a complete anion, the calcium still has that electron it's trying to get rid of. So in this problem, we're going to draw a second chlorine atom so that the calcium can get rid of its second electron. And now both chlorine anions have 8 valence electrons. They're both filled. They're both complete. Calcium here has gotten rid of both of its electrons. And again, if you get rid of electrons, the atom becomes more positive. In this case, it's going to be positive twice. And that calcium forms what's known as a cation. So here we have to look at our formula. We have 1 calcium atom and 2 chlorine atoms. So when I do my formula, the metals always go first. So I'm going to do CaCl, and since I've drawn 2, I'm going to represent that 2 with a subscript 2. Okay, so my CaCl subscript 2. The name is going to be calcium dichloride. All right, that Di means that there are two of those represented. All right, so you're going to do the rest of the problems on your own. And if you have 2 atoms drawn, you'll use di as a prefix. If you have 3 atoms drawn, you'll use tri as a prefix. So maybe if I drew another chlorine for some reason, it would be trichloride. Okay, just as a prefix there. Okay, good luck with the rest of your problems.